Hello, everyone, and thank you for joining me today. I'm excited to share our project on predicting loan defect using the advanced machine learning and explainable AI technique. The long-term goal of this work is to develop the classifier that not only accurately predict whether the customer will defect on loan, but also provides the transparent insight into the decision-making process. This is especially critical in financial risk assessments, where the trust, the fairness, and the transparency drive better business decision. So we start by exploring our loan default data set to understand its shape, the column, and the data type. Our initial analysis involved checking the duplicates and the missing value. For instance, we found some missing values um, in feature like the title, the employment title, and the DTI. We address this by filling them with median or model value, ensure that our data was clean and ready for analysis. Next, we separate the numerical from the categorical feature and apply label encoding to categorical variable like a grade and the early credit line. To ensure our data distribution was helpful modeling, we applied the box cross transformation here. For the skipness correction, you can see on the screen of series of histogram and the box plot comparing the original distribution against the transformed data. This visuals demonstrates how we reduce the skewness to ensure more reliable model performance. We also tracked the outlier using here. Here. Here, we also tracking the outlier using this sigma rule, flagging and removing the extreme values. This step help us to stabilize the data set and prepare it for training. Finally, we split the data prediction and the target variable applied the smooth. Here. To balance the classes, balancing the data set is key to avoiding the bias prediction when the default are loss frequency. Once the data are ready, we moved to the model development. We started baselines using the logistic regression to improve the performance. We used the PyCaret's low mode interface to rapid examination with PyCaret. We compared the multiple models and determined the hyperparameters through the grid search and the cross-validation. One of the highlights of XGBoost, we began with a baseline attributes classifier and then perform a hyperparameter tuning, vary parameters such as the number of estimator, max diff, the learning rate, and the subcenter ratio. This turning process, as shown on our read, the research output significantly based on the AUC and the overall accuracy of our model. You will notice on the screen the learning curve confusion matrix would prove a snapshot of the model performance on both training and the test data set. Here. So now we can predicting the default is not enough. The crucial understanding the why behind the model decisions. There is our explainable AI or XAI technique become into a play. We integrate our four explanation method to our project. First is called SHAP. Using SHAP, we generate a summary plot that reveals how each feature, such as the interest rate or the employment title, impact the probability or default across the entire data set. This goal are explained how allow us to identify which feature most strongly drive into the model prediction. The second is called LIMN. Here. For local explanation, we employ the LIMM by selecting the individual instance. The L line breaks down the prediction into contribution from each feature, offering the clear view into the decision-making process for that particular case. And third one is particle depending plot. This plot illustrates the average effect of the selected feature on the predicted probability on default. For example, the particle dependence plot for interest rates shows how change in interest rates affect the likelihood of default, providing the intuitive insight for both technical and the non-technical audience. The fourth is Sorogan decision tree. Lastly, we use decision tree as the surrogate model. With shallow tree structure, it approximates the behavior of our black box the model with while remaining the interpretable. This helps the stakeholder understand the decision boundary in simple visual terms. The combination of this model ensures that our model is not only accurate but also transparent and understandable. Four is ethical consideration are at the heart of any financial model. We look here of examining potential bias in our data, such as those arising from the demonstrate or our regional factors. Our fairness analysis ensures that models' decisions were not skewed against any particular group. This is visual, especially when the model outcomes can directly impact the critical decision and the customer trust. By integrating the fairness metrics and the ethical reflection into our workflow, we make sure our model adhere to responsible lending particle. In evaluating our model, we focus on the key metrics like the accuracy, the AEU, the prediction, and F1 score. We turn the XGBoost model, for instance, showed marked importance in the performance. On the screen, you can see the ROC curve here and the confusion matrix, which systematically summarize our results. The ROC curve demonstrates the model's ability to discriminate between the default and the non-default case, while the confusion matrix confirm the balance between the sensitive and the speculative. Specifically, we also compute the permission future importance to assess the contribution of each feature, which further validates our examinability method. This evaluate not only showcase the technical robust of our model, but also boosted the business case for using such system financial risk management. Before concluding, it's important to reflect on our process. Our approach combination robust data pre-processing, the advanced machine learning, and the state-of-the-art XIAI technique, while the model was demonstrated strong performance and the transparency. There's always a room for important improvement. The future work would involve incorporating the additional fairness metrics and refining the hyperparameter using the strategies or even exploiting the enable method that can blind the multiple explanatory models. Thank you.